Good morning all. Today we will discuss another morphological operation, that is convex hull. So before discussing convex hull, first we will discuss what is a convex set. So in order to explain what is a convex set, here I have two digital images, digital image 1 and digital image 2. So in digital image 1 and in digital image 2, this shaded portion it represent my object part. This shaded portion it represent my object set. So for example, in digital image 1, the object set, let's suppose it is represented by S1. And in digital image 2, the object set, it is represented by S2. Now, in set S1, I will choose 2 points, this point and this point. I will choose a pair of points and I will connect them with a straight line. If this straight line it passes through the object set, then this set S1 it is called as the convex set. So once again, in object set I choose any two point, that is I have chosen a pair of points and I connect them with a straight line. If this straight line it passes through all the object pixel, if this straight line is passes through the object sets, then we say our object set it is convex in nature. Otherwise, in this digital image S2, I choose 2 points, I choose a pair of points and I will connect them with a straight line. Now this straight line it is not passing through the object set. In other words, this straight line it is not passing through the object pixels. It is passing through this white pixel and this white pixel are my background pixels. So in this straight line, since this straight line it is not passing through the object set, since this straight line it is not passing through the object pixels, we will say this object set S2 it is not convex in nature. So in object S1, I choose any 2 points, I choose a pair of points, I connect them with a straight line and this straight line it is passing through the object sets, it is passing through the object pixel. We will say the set S1 it is convex in nature. On the other hand, in this object set S2, I choose 2 points, I choose a pair of points, I connect them with a straight line and this straight line it is not passing through the object sets. This straight line it is not passing through the object pixels. So we will say this object set S2 it is not convex in nature. So far we have learned, suppose we have a set S, suppose we have an object set S, and in this object set S I choose 2 points, I choose a pair of points and I connect them with a straight line. If this straight line is passing through the object sets, it passing through the object pixel, we will say the set it is convex in nature. On the other hand, if the straight line it is not passing through the object set, it is not passing through the object pixels, we will say the set it is not convex in nature. Now let us discuss the definition of convex hull of a particular set S. So convex hull of a particular object set S, it is defined as it is the minimal set which contains the set object set S and which is convex in nature, and it is called as the convex hull of the set S. So usually convex hull it is represented by H. So H is the convex hull of the set object set S, and H minus S it is called as the convex deficiency. So all these terms that for a particular object we will determine the convex hull, and for a particular given object set we will determine the convex deficiency in our later example. So in order to perform the convex hull operation, we will use a set of structuring element, and these are the four different structuring element, or I can say these are the set of structuring element these are the set of structuring elements which we will use in convex hull. So this structuring element it is represented as B0, B1, B2 and B3. So using these four structuring element, we will perform our convex hull. We will determine the convex hull for the given object set S. In order to determine the convex hull for a given object set S, we have to perform some iterative operation. We have to perform some iterative operation with this structuring element B0, B1, B2 and B3. So for this, let us assume Bi is a structuring element, is a particular structuring element and in our operation this I we will vary from 0, 1, 2 and 3. The iterative algorithm for convex hull is as follows. It is given as xki is equals to xk minus 1I heat or mass with the structuring element Bi union with the original image set A. So the iterative algorithm in order to determine the convex hull, it is given as xki is equals to xk minus 1I hit or miss with Bi union with the original image object set A. Let's suppose for a particular structuring element Bi, the initial point to this iterative algorithm it is given as x0I, that is equals to the original object set A. So for a particular structuring element Bi, we have to start our iterative algorithm, that is x k equals to 0, particular structuring element I, it is equal to the object set A. Then we have to perform this iterative algorithm with a number of times till we reach our point of convergence, that is xki, it is equals to xk minus 1 I. It means two consecutive iteration of a particular structuring element, when it gives the same output, we will say we have reached our point of convergence. And this point of convergence, let's suppose it is represented as xi convergence, it is represented as di. For a particular structuring element bi, we have initialized our iterative algorithm considering the original image A, considering the original object set A. Then we perform this iterative hit or miss transformation. Then we perform this iterative algorithm till we get the point of convergence. That is two consecutive iteration operation. When it gives me the same result, we will say we have reached the point of convergence. At point of convergence, that is xk of I, we will consider it is my convergence result for this ith structuring element, and we will represent it with di. Now at the end, when you perform the union of di, now when we perform the union of di, where I varies from 0 to 3, we will say this is our convex hull for this given object set A. So we will discuss with an example how to determine convex hull for a given object set A. So for the same, here I have one example. This is my input image I. This is my input image I, and this is the object set. Now this object set, it is not convex in nature, since if I choose any 2 points, for example, if I choose this point and this point, if I connect this pair of points, the straight line will not pass through the object set, and hence this object set, it is not convex in nature. In order to perform the convex hull operation, we will use these 4 structuring elements B0, B1, B2 and B3 on this input image, on this object set I, and we will determine the convex hull for this given object set I. So now let us start our iterative algorithm with the structuring element B0. So look at the structuring element B0. The center pixel, it is logic 0, and these 3 pixels are logic 1, and remaining 5 pixels are don't care. So with this structuring element, we will perform the hit or miss transformation on this given input image, or on this given object set I. So for this hit or miss, so for this convex hull operation, we will use some color. For example, we will use blue color for this structuring element B0. We have to perform hit or miss transformation of this structuring element such that the center pixel, it is logic 0, and these 3 pixels are logic 1, and remaining 5 pixels are don't care. So we will try to find this pattern. The center should be 0 and these 3 pixels should be logic 1 on this given object set I. So if you try to find those center pixel whose center pixel is logic 0 and these 3 pixels are logic 1, that is the hit condition on this object set I, we will find this pixel, and this pixel For this 3 pixel, we will find the hit condition. That is, for this pixel, the center pixel, it is logic 0. Since this shaded portion, it represents the logic 1, and this unshaded portion, it represents the logic 0. So here my center pixel, it is logic 0, and these 3 pixels are logic 1. So this is my hit point. For this pixel also, the center is 0 and these 3 pixels are logic 1. So this is my another hit point. And for this pixel also, the center it is logic 0 and these 3 pixels are logic 1. So this is my third hit point. So we will mark these hit points. Now since these 3 hit points, it belongs to my 0th iteration, so I will use the indexing 0. Now on this intermediate result, again we will perform hit or miss transformation with this structuring element B0 till we get the point of convergence. So on this intermediate result, if we perform the hit or miss transformation with this structuring element B0, that is, we have to find this pattern. The center should be 0 and these 3 pixels should be logic 1. We will find this pixel, and this pixel are the hit point in my first iteration. Since my previous iteration, it is the 0th iteration, so my current iteration, it is my first iteration, and these 3 points are my hit point belonging to this structuring element B0. Here also, if we find the center, it is 0 and these 3 pixels are logic 1. For this pixel also, the center it is 0 and these 3 pixels are logic 1. And for this also, the center is 0 and these 3 pixels are logic 1. So let me mark these 3 hit points. And since these 3 hit point, it belongs to my first iteration, so I will write here the indexing 1. Again on this intermediate result, we will apply this structuring element B0 and we will try to find this pattern. The center should be 0 and these 3 pixels should be logic 1. So if you try to find those hit point on this intermediate result, you will find only these 2 are the hit point belonging to my second iteration. The center is 0 and these 3 are logic 1. The center is 0 and these 3 are logic 1. So these are the 2 hit points belonging to my second iteration. Let me mark these hit points, and for second iteration I will use the indexing number 2. Further, if I apply further on this intermediate result, if I apply B0, we will not find any hit point. It means with B0 we have reached the point of convergence. Next we will try for the structuring element B1. Next we will try with the structuring element B1. For B1, again we have to perform the hit or miss transformation on this given intermediate result, and we will try to find this hit pattern. The center should be 0 and above 3 are logic 1. And for B1, in order to mark B1, we will use some different color. That is, we will use for B1, we will use the orange color, and we will try to find out this B1 pattern. The center should be 0 and above 3 are logic 1. If you try to find this pattern on this given intermediate result, we will find this point and this point are my hit point. Here also my center is 0 and above 3 are logic 1, and here also my center is 0 and above 3 are logic 1. So now let me mark these hit points. And since overall this is my third iteration, so I will use the indexing 3. Next, again on this intermediate result, we will apply the hit or miss with this structuring element B1, we have to find those hit point where the center pixel is 0 and above 3 are logic 1. So if you try to find the hit pattern for this structuring element B1, you will find this and this are my hit points. Here also the center is 0 and above 3 are logic 1. Here also the center is 0 and above 3 are logic 1. So let me mark these two hit points. And since these two hit points, it belongs to my fourth iteration, so here I will write 4. Again on this intermediate result, we will apply hit or miss transformation with this structuring element B1. So we have to find this pattern. The center is 0 and above 3 are logic 1. So we got only one hit point, that is this hit point. Here the center is 0 and above 3 are logic 1. So let me mark this. And since this hit point, it belongs to my overall fifth iteration, so I will write here 5. Again on this intermediate result, again we will apply the structuring element B1, and we will try to find this pattern. The center is 0 and above 3 are logic 1. So we will find only one hit point, that is this pixel. Here the center is 0 and above 3 are logic 1. So let me mark this pixel also. And since this hit point, it belongs to my overall sixth iteration, so I will use here the indexing, that is 6. Further on this intermediate result, if I apply B1 and if you try to find this pattern where the center is 0 and above 3 are logic 1, we will not find any new hit points. So we will say with B1 we have reached our point of convergence. Next we will try with the structuring element B2. Next we will repeat our iterative algorithm. We will repeat our iterative algorithm with this structuring element B2, and in B2 you can see the center pixel, it is logic 0, and these 3 pixels are logic 1, and the remaining 5 pixels are don't care. So we will so this pattern. So in order to target the hit point in the given in this intermediate result, we have to find this pattern. The center should be 0 and these 3 pixels should be logic 1. So if you try to find the hit points belonging to the structuring element B2 where the center pixel it is logic 0 and these 3 pixels are logic 1, on this intermediate result you will find 2 hit point, this hit point and this hit point. Here also the center pixel it is logic 0 and these 3 pixels are logic 1, and here also the center pixel it is logic 0 and these 3 pixels are logic 1. So for B2, so in order to mark these 2 hit point, for B2 structuring element we will use some different color. We will use this purple color. So let me mark these 2 hit point with this purple color. And since these two hit points, it belongs to my overall 7th iteration, so I will use here the indexing 7. Next, on this intermediate result, again we will apply B2. Again we will perform the hit or miss transformation with this structuring element B2, and we will try to find the hit point belonging to the structuring element B2 such that the center pixel is logic 0 and these 3 pixels are logic 1. So if you try to locate this pattern, try to find the hit point belonging to this structuring element B2, you will find only one hit point, and this point where the center pixel is 0 and these 3 pixels are logic 1. So let me mark this pixel also with this purple color. And since this hit point it belongs to my overall 8 iteration. So here I will use the indexing number 8. Further on this intermediate result, if I perform the hit or miss transformation with this structuring element B2, I will not get a new hit point. I will not get any other hit points, which indicates that the point of convergence with this structuring element B2 has been reached. So now next we will try with the structuring element B3. Next we will repeat this iterative algorithm with the structuring element B3. In structuring element B3, the center pixel it is logic 0 and these 3 pixels are logic 1 and the remaining 5 pixels are don't care. So we will try to find the hit point belonging to this structuring element B3 on this intermediate result. So if you try to find the hit points belonging to this structuring element B3, we will get only one point, and that is this point. In order to mark this hit point, I will use some different color for this structuring element B3, and we will use the red color. So we will mark this hit point which belongs to this structuring element B3, and since this hit point it belongs to the overall 9th iteration, so here I will use the indexing 9. Further if I apply the structuring element B3 and if I try to find the hit points belonging to this structuring element B3, we will not find any new hit points. It means with the structuring element B3 our point of convergence has reached. So far we have performed the iterative algorithm with the structuring element B0, B1, B2 and B3. So if we remember the definition of convex hull, for a given set S, it is defined as it is the minimal set which containing the set S and which is convex in nature. So in order to draw the minimal set for this given object set I, this shaded portion which I mark with this pen, it is my object set, and these color points, it belongs to the result of hit or miss transformation with this structuring element B0, B1, B2 and B3. So we have to draw the minimal set which contains my original object set S, or my original object which contains my original object set I. So in order to draw the minimal set which contains my object set I have to draw the boundary of the given original object set I. This is the boundary of the given object set I. So in order to select the minimal set which consists the original set I have to draw this boundary of this given object I. Now the point which lying inside this minimal set, I will consider them, and remaining the pixels which doesn't lie inside this minimal set, I will remove it. It means inside this minimal set, the result belonging to the 0th iteration, the result belonging to the first iteration, the result belonging to the third iteration, the result belonging to the fourth iteration, the result belonging to the fifth iteration, and this result which belongs to the 7th iteration. We will consider these hit points and the result belonging to the second iteration, the result belonging to the ninth iteration, the result belonging to the sixth iteration, and the result belonging to the eighth iteration, and this result which belongs to the iteration number 7. We will neglect these hit points since these hit points doesn't lie inside this minimal set. So now look at here. This is my original object set I, and this is the minimal set. This is this brown line. It represents the minimal set which contains the original object set I, and these are the hit point which belonging to the different structuring element B0, B1, B2, and B3. So for simplicity, I will mark all these hit point with a common color. So here I mark all the hit points which we obtained as a result of iterative algorithm with different structuring element B0, B1, B2, and B3. So this yellow point, it represents those hit points. So this image, now this image which is minimal in nature, which consists of the original object set I and which is convex in nature. So this object set, this set, it is called as convex hull H. This was my original object set I, and if I subtract this original object set I with this convex hull H, I will obtain H minus I, that is called as the convex deficiency. So for this given object set I, we have obtained the convex set H, and H minus I, we have obtained its convex deficiency. With this morphological operation, convex hull is over. Thank you.